Let us start today's class and we will discuss about the VFDs, DMDs and LEDs, dot matrix display and LED. So visual fluorescent display. A vacuum fluorescent display is a display device once commonly used on consumer electronics equipment. So LCDs, OLED displays and LED segment displays have now largely replaced vacuum fluorescent display. A vacuum fluorescent display operates on the principle of cathodoluminescence, roughly similar to a cathode ray tube, but operating at much lower voltages. So next, coming to dot matrix displays. Excellent alphanumeric characters can be displayed by making use of dot matrix LEDs with an LED at each dot location. A 3x5 dot matrix, you can see here on the diagram I have shown a dot matrix display, how it will be there. It is used for display of numeric characters. Dot matrix making use of 27 dots. It will make use of 27 dots. This system displays the numeric characters as I mentioned earlier. The dots may be square or round with 0.4 mm side or diameter. That is LEDs and LCDs are used for display of dots. Please make clear of it. The 5x7 is most popularly 5x7 dot matrix format is actually most popularly used in LED arrays and CRTs. The 5x7 dot matrix format enables a far larger set of typically 192 characters to be obtained, including all the numerals, upper and lowercase letters, together with Greek letters and other symbols. A 7x9 dot matrix format provides a better representation of lowercase letters. The various alphanumeric characters are displayed by lighting up the LEDs, located in specified positions. For better brightness of display and economy in hardware, a dynamic display scheme is used. So in this scheme, the LEDs are not lit continuously, but are sequentially lit by scanning in a vertical strobe or horizontal strobe mode. In the vertical strobe mode, information is addressed to the display by selecting a single row at a time, energizing the appropriate LEDs in that row, and then proceeding to the next row. In the horizontal strobe mode, a single column is chosen at a time. The functional diagram for a 3-digit alphanumeric display system making use of horizontal strobing is very important. The alphanumeric are represented by a code of specified word length generated by the keyboard. The ASCII code is one of the most widely used formats, used with keywords giving 64 alphanumeric characters, including 26 English alphabets, 10 numerals, and several other symbols. So here we can refer, you look at the diagram, ASCII code from the keyboard is sequentially entered and stored in 3 input storage buffers. The codes in the input buffers refers to the 3 individual characters to be displayed. So like this it goes on. The appropriate characters can be displayed. So in the dynamic display, however, only one column is energized or driven at a time, and the 5 columns are driven sequentially. When the first 5 columns have been driven, a timing pulse changes the code input to ROM to correspond to that stored in buffer 2. Similarly, when column 11 to 15 are being driven, the data to the ROM is from input buffer 3. After all, 3 columns have been driven, the sequence repeats. So if the repetition rate exceeds about 20%, A flicker-free array of alphanumeric characters is obtained. So coming to LED display. The best known of all optoelectronic devices is the so-called LED light emitting diode, which emits a fairly narrow bandwidth of visible, usually red, orange, yellow, or green. So, or invisible infrared that is infrared light, when its internal diode junction is stimulated by a forward electric current or voltage. LEDs have typical power to light energy conversion efficiencies, some 10 to 50 times greater than of a single tungsten lamp, and have a very fast response times, approximately 0.1 microsecond compared with tens or thousands, hundreds of milliseconds for a tungsten lamp, and are thus widely employed as visual indicators and as moving light displays. The operation of this LED is based on the phenomenon of electroluminescence, which is the emission of light from a semiconductor under the influence of an electrical field. The recombination of charge carriers takes place in a forward p-n junction as the electrons cross from the n region and recombine with the holes existing in p region. So free electrons are in the conduction bond energy levels, while holes are in the valence energy band. Therefore, the electrons are at high energy levels than the holes. For the electrons to recombine with the holes, they must give some of their energy. Typically, these electrons give up energy in the form of heat and light. In silicon and germanium diodes, most of the electrons give up their energy in the form of heat. However, with the gas and GAP GaAsP and GaP semiconductors, the electrons give up their energy by emitting photons. If the semiconductor is translucent, the light will be emitted and the junction becomes a source of light, that is a light emitting diode. LEDs emit no light when reverse biased. In fact, operating LEDs in reverse bias mode will quickly destroy them. The semiconductor, as I have discussed here, so these are the LEDs can be manufactured to produce light of virtually any color. It provides, so to list some of common compound semiconductors and the light they produce, that is color amber, that is blue, green or red, yellow, red, white, yellow, like that. So LED displays are available in many different sizes and shapes. The LED light emitting region is available in lengths from 2.5 to 25 mm. So numbers can be created by such segments. So typical arrangement, see, these are the few, introduction about the LEDs and construction, how it will be done. So what are the advantages of LEDs? So the advantages is smooth control of light intensity from an LED, because light output from an LED is a function of current flowing through it. And these LEDs are economical and have a high degree of reliability because they are manufactured with the same type of technology and is used for transistors and ICs. LEDs are rugged and can therefore withstand shocks and vibrations. And LEDs can be operated over a wide temperature range. The switching time is always less than 1 nanosecond. So they are very suitable where a dynamic operation of large number of arrays is involved. So LEDs are available in different colors, as I mentioned. So they need moderate power. They are used where low DC power is available. They occupy actually small area. So LEDs devices can be driven by a transistor logic, that is TTL, whereas gas discharge devices need intermediate transistor stages to allow them to be driven by 5-volt TTL. So LEDs that emit visible light are widely used in instrument display panel indicator, digital watches, calculators, multimeters, intercom, telephone switchboards, etc. So LEDs that emit invisible infrared light find application in remote control schemes, object detectors, burglar alarm systems, and other areas requiring where invisible radiation.